Welcome to the Lawrence University Career Center podcast. I'm Ty Collins, and joining us today is Trace Hybertson from the Lawrence University class of 2019. Trace earned his bachelor's degree in math, computer science, and was president of Fiddlers of Lawrence University. After graduating, Trace became a software engineer for FIS in Milwaukee, and today is a software engineer at OptTek Systems in Boulder, Colorado. Welcome to the show, my friend.
Thanks for having me, Ty. It's a pleasure to be here.
Trace, you're already 6 years out of Lawrence. Looking back, what do you most remember about your time here at LU?
So I was just thinking about that because yesterday was CU Boulder's graduation. So I saw a lot of happy seniors walking around in caps and gowns. And of course, it fondly made me remember my own time at Lawrence. What I probably remember most is the connections I made, the academic connections, professional connections, and of course, all the friendships. I was lucky enough to make what I hope will be some lifelong friends. And then, of course, I remember the Lawrence busy. I work full-time as a software engineer and a professional musician, and I'm not as busy as I was when I was at Lawrence.
That often tends to be the case, I've found, with alumni. Currently, you're a software engineer at OptTek Systems in Boulder, Colorado. Tell us about your company and what it is you do there.
Yeah, so OptTek is, pulled from their website, the world's leader in complex systems optimization, serving a wide range of clients and partners in the private and public sectors. Putting that in simpler language, we write simulation optimization software that empowers our clients to build a better and safer world through AI-enabled optimization and analytics. Simulation optimization and operations research are pretty niche fields and a little bit confusing, so let me give you a simple example. Imagine that you are starting up an ambulance service for a small city. You've got the budget to build 5 stations anywhere in the city, and you want to know where to put them. Obviously, the best location to put them would be the ones that minimize the average response time to anywhere in the city. One smart way of figuring out where you might want to place these stations is to build a computer simulation. With that, you can model average traffic, distances to get to any call, to get an average response time, etc. But you would still need some analyst to sit there and say, what happens if I move this station a block away? Or this other station 2 blocks away? So the computer simulation will solve one problem, but it won't give you any sort of accurate analysis without a lot of work, like guess and check work, essentially, by some data analyst. Our software solves that problem. It's the optimization of the simulation itself. Using meta-heuristic algorithms, our software will wrap your simulation and find an optimal station placement map, as well as providing a rich data analysis of all your options. So that's a simple toy problem to kind of explain what simulation optimization is, but that gives kind of an overview of the software that our company provides. So as for what I do there, I'm a software engineer. I'm a full stack software engineer at OptTek, which means that I'm writing algorithms and features, fixing bugs, maintaining code, and sometimes I get to go actually help our clients write the computer models and simulations themselves and come up with the ideal optimization parameters and settings for them.
Can you walk us through a typical day? Try to make it simple for us non-tech folks.
Yeah, so one of the things that I love about OptTek is that due to our diverse client portfolio and the small size of the company, we're about 20 people, my days vary a lot. So some days I might be writing new code to build a new feature. Sometimes I might be spending all day fixing annoying bugs and then creating new ones and having to fix those. Debugging is always really, really fun. Sometimes I'm reviewing customers' projects. Sometimes I'm reviewing coworkers' code. Sometimes I'm sitting in on planning meetings for new features on particular projects. And I've even been out on site at our customer locations, helping them integrate our software or to actually run some studies. I've also helped with some BD efforts at conferences and all of that. So that's a little unusual that I get to do all this, feature development, testing, QA, front-end design, back-end algorithm work, integration. At a larger, more standard tech company, I'd probably only be doing one of those things. But one of the things that I love is that I get to do it all.
Wow. So you work for a company with 20 people right now. Before OptTek, you were at FIS, which is a Fortune 500 company with thousands of employees around the world. Can you talk about what it's like to work for a small organization versus a giant one? And do you find you have a preference?
Yeah, both have their ups and downs. Large companies, you're typically doing one thing for one product line and one team. Whereas at a small company, I know my entire company, right? There were like 20 people and you get to do a lot of different things. Large companies can tend to be more stable and less subject to financial whims of the day. though FIS, I did read recently had layoffs, as a lot of tech companies are. I prefer working at smaller companies because I find it more easy to know the mission of the company, to be able to go up to my CEO and say, hey, what are we doing with this? I've got an idea for X, Y, or Z, etc. Whereas at a Fortune 500 company, I never met the CEO. I barely met anyone outside of the small team I was on.
Some of the work you do is with object-oriented programming, Java, C++, C Sharp, modern web frameworks. But I know when you left Lawrence to work at FIS, you worked with legacy systems like COBOL and IBM mainframes. The latter of two are not taught at Lawrence. Can you talk about how you learned these older systems? And then more broadly, how do you keep up on the latest trends and updates in the software development field?
Yeah, so my current work is all on modern platforms. Lately, I've primarily been working in Java, Python, and some proprietary scripting languages. But as you mentioned, my first job out of Lawrence was in COBOL on a IBM mainframe ZOS system. I learned those old systems by kind of just being thrown in the deep end. And there's actually kind of a funny story about that. I was interviewing for the junior software developer role at FIS Global in Milwaukee. And I remember I had to skip a class and drive down to Milwaukee for that final on-site interview. And the whole time, everything from when I saw the job posting online and submitted an application to the initial phone screen, to the initial phone interview, all through the final interview, it was all in Java. The job was billed as Java. The code I wrote in the interview was in Java. It just seemed like a standard, normal programming job. And then as the interview was wrapping up, I was asked one last question, and it seemed like almost an afterthought. It was, would you be willing to learn a little bit of COBOL in this job? And I said yes, because that's what you would say in an interview, is what I figured. And what could it hurt? It turns out that out of the whole crop of like the new grad program that they hired, I guess I was the only one who said yes, because I was the only one who was immediately put on the COBOL team and stayed there. I never wrote a single line of Java the entire time I was at FIS, so I learned quickly. COBOL is so old that the online references, at least at the time, were somewhat limited. So some of my experienced coworkers dug out this thing that people might remember called books. I was handed a stack of books to learn COBOL. I took them home, and within about 2 weeks, I was starting to actually code in COBOL. So trial by fire, but that's how I learned it. And it was actually Lawrence's unique kind of combined math CS program that really prepared me well for that. Because at Lawrence, at least the program when I was there, we prioritized, obviously we learned to write code, but we more prioritized the data structures and algorithms, the how and the why and the theory of what computer science is and the mathematics behind it. So I was able to pick it up a lot faster. I was able, because I had a basis in what code is and why it runs, as opposed to how to write many lines of code. That framework that Lawrence gave me enabled me to pick up COBOL quite quickly, and I'd say the same about the stuff that I'm doing today. I've been working in a lot of different languages, Java, Python, C Sharp, C++. The only one I knew when I started was Java and some C++. But I don't really mind that, because once you understand the underpinnings of the why, it's all just syntax, and that's easy to look up.
Yeah, definitely when someone asks you, can you do something in an interview, you should say yes. So nice job.
Yeah.
I wanted to get your thoughts on AI's effect on the software development lifecycle. I read a lot about how it's transforming development and engineering by automating processes, accelerating development time, improving code quality, reducing costs. Where do you see this going, and does it make you worry about job opportunities in the future? You did say a few minutes ago that your last company has been laying people off. How do you see AI impacting the software development field?
Yeah, AI, the next big new thing. Specifically talking about large language models, which is what most people are familiar with and think of when you say AI. Services like ChatGPT, Claude, Llama, DeepSeek, all these large language models AI that it seems like they can just generate anything. I'm getting more and more impressed with what they say they can do and what it looks like they can do on the surface, and also less and less impressed with what the end result is. Specifically for coding, it's getting better and better. It's getting shockingly better at a rapid rate. But to me anyway, and this is my opinion, it's still really only good at boilerplate and writing a few lines of code at a time if you get stuck on some syntax. I wouldn't trust it with logic or writing like whole programs at a time. I know it says it can do it. I've got friends who say they do it, but I don't trust that. And that's because there's a lot of studies that say it accelerates development time, which is true, but that it's also a detriment to code quality, which is also true. If you don't understand what every single line of code is doing. Or if someone at the company who didn't write the line of code didn't go through line by line what the AI is producing, you're introducing a tremendous amount of what's called technical debt, which is basically you make a short-term gain for long-term trade-offs. Sometimes that's fine. If you're just trying to get some minimum viable product out the door to show an investor, by all means, that's fine. But technical debt in general is a really bad idea because you might be saving money now, but the whole point is that you're in debt to your technical stuff. You owe it later, and you're going to end up with a lot of problems down the line. Yeah, it's fascinating with what it can do, but I don't trust the technical debt. And there's a lot of unanswered questions about the ethics and security risks, the ethics of saying you wrote code when the AI wrote it, or just like the ethics of all the data centers that are being used and the bottle of water per query it takes type of thing. That being said, it's obviously a new and growing field. It's huge and it's worth keeping track of what it can do and knowing how to use it. As far as job security, I really don't know. I do sadly think that the short-term speed and the shininess of these new capabilities are going to make junior dev jobs in shorter and shorter supply. And I think they're going to make all of software engineering look different, though I really don't know how. And I would say it's worth knowing how to use these systems. It's also still definitely worth knowing how to code yourself.
Well, thank you for that. And it's a good lead into our next question, which is for LU students currently in computer science programs and those still to come. What's your best advice for those looking to launch their career in the IT industry?
Be willing to say yes to things. Saying yes led to me getting a job in COBOL, which I wouldn't wish on anyone, but hey, it was my first job and a step in the door. Being willing to say yes to things, being willing to learn new skills, new languages, new platforms, it won't hurt. You can always say no later if you don't like it. Don't say yes to everything, if you don't want to do it, but be willing to say yes. Code is everywhere, right? If you look around the room you're sitting in, it's not just your computer, it's your car, it's your clock, it's the watch you're wearing. If you want to work in tech, there are so many different industries and fields and jobs that you never knew existed. My current job in the broad category of operations research, I had no idea what that was before I started applying to this job and got it. I'm working on code and working on projects that I wasn't even aware of. Same with my last job, actually. Like it was financial processing and bank transactions. And I knew there was code behind that, but I never thought about it. When you go to the bank and deposit money or use an ATM, you don't think about the code that's running, but someone needs to write that. So being aware that there is a absolutely massive industry and not limiting yourself to just wanting to work at a tech company, like one of the FANG companies or smaller tech company. Be aware of that tech is a lot. There's a lot of different opportunities and be willing to say yes to this.
I would like to switch gears from tech to the more creative side of you. You mentioned it when we started. The other side of you is music. You are a performer. You were the president of the Fiddlers at Lawrence University. You do still play. I've heard and seen some of your stuff online. I know you occasionally collaborate with some other Lawrence alumni. Tell us more about the music side of Trace.
Yeah, I started playing violin and fiddle when I was 4, and I haven't been able to put it down since, including at Lawrence. I don't have a music degree from Lawrence, but I did music there all 4 years. I took violin lessons, played in the orchestra, took the music theory sequence, et cetera, et cetera. And I still play now. My current project is a band called Trace and Baird. It's me and a guitar player. And last August, I got the chance to do one of the coolest things I've ever done in my life, which was go down to Nashville and record an album with an incredible team of some Grammy-winning people. And that's been amazing. I'm still actually playing a gig tonight, trying to really get this band off the ground and touring more, and that's been really fun. I should also mention that the confidence and the idea to record this album came in large part due to one of my friends from Lawrence who ran the Fiddle Club before I did, Isabel Damon, who recorded an album with some of the same people down at the same studio in Nashville and helped me put all that together.
I'll put a link in this episode's description to your music so people can check that out. But that's really awesome. I listened to your album the other day all the way through. It's amazing. So very nice job. It's great to listen to. So
Thank you.
How does that creative side of performing music complement the more logic side of being a successful software engineer?
I actually find a ton of similarities between coding and being a software engineer and playing music. Both are logical yet creative. Both are forms of communication, both require dedication, practice, hard work, and iterative improvement. Basically, I find that they use the same part of my brain because writing code is, yeah, it's incredibly logical, but it's also incredibly creative. And I'd say the same thing about music. There's a surprising amount of musicians that I know that have a software engineering or just other engineering background. When I was interviewing for all my jobs, I always bring up the music aspect because it just really highlights those soft skills and the importance of perseverance and dedication and seeing something through to completion. Both provide an immense amount of joy in my life.
As we are approaching the end of our time together, last question here. Looking back at that transitory time of leaving college and entering the full-time workforce, did anything stand out as surprising or cause any of those "I wish I had known that" moments that maybe you'd like to share with some current students?
One thing that I should have intuitively known, but just kind of didn't, is that I went from juggling, 3 to 5 classes at Lawrence in disparate topics. I might have been taking a Latin class, a piano class, and a data structures class to be focused on one project at one company for 8 or 9 hours a day. And going from that incredibly disparate, I'm focused on this, to one thing, I had to quickly learn how to not go too deep and get lost in the weeds because I didn't have that just kind of natural, okay, now it's time to go do my Latin homework. I found it easy to get lost in the weeds and I had to learn how to not. Part of it, though, was quite literally the context switching of I wasn't used to sitting down and doing 8 hours of one thing at a time, which was definitely interesting. Then just the college life to office job was also obviously a big transition.
Yeah, it certainly is a big transition, but we all make it through. Trace Hybertson from the Lawrence University class of 2019, thank you for joining us on the Lawrence University Career Center podcast.
Thanks for having me, Ty.